We are asked to find the vertical asymptotes for this rational function. A rational function is a quotient of two polynomials. To find vertical asymptotes, what we first do is make sure that the two polynomials are reduced. So I'm going to factor and cancel if possible. Well, if we look at this, we see that the two expressions x minus 5 and x squared minus 5 cannot be reduced further. So to find vertical asymptotes, what I'm going to do is look at where the denominator is equal to 0. A vertical asymptote is going to be a vertical line, so it's going to be the line of the form x equals some constant. And we look for those where the denominator is equal to 0. So I'm going to look at the denominator, x squared minus 5, and I'm going to set that equal to 0. And solve. X squared equals 5. So x is plus or minus the square root of 5. So these two lines, x equal radical 5 and x equal negative radical 5, are the two vertical asymptotes. If I plug in values of x close to radical 5 into the function, I will get values of y which are very, very large. As x gets closer to radical 5 or closer to negative radical 5, the y values get larger and larger. To find the horizontal asymptotes, I ask the question, what happens if x gets very, very large? And I'll indicate that with that symbol. So what I want to do is plug in very, very large values of x and see what happens to y. Well, one of the ways to do that is to look at this expression, x minus 5 over x squared minus 5, and realize that for large values of x, the only things that count are the two highest powers of x. So I'm going to look at x over x squared instead. Well, that's the same as 1 over x if I reduce it. So for large values of x, the original expression is very much like this expression. And here it's pretty easy to see that if x is very, very large, the y value is very close to 0. So I'm going to say that y equals 0 is the horizontal asymptote. It's a horizontal line. The function gets close to y equals 0. This, in fact, is the x-axis. In the answer to part C, there are no oblique asymptotes. Oblique asymptotes will occur when the degree in the numerator in the top is 1 more than the degree in the bottom, or the denominator. So if the degree of the numerator is 1 more than the degree in the denominator, then we'll have an oblique asymptote. Otherwise, we don't.